Welcome to the complete walkthrough of Section A of the International Baccalaureate Mathematics. Analysis and Approaches IB Higher Level Paper 1. Question 1. Let A and B be events with given probabilities. Find P of a given B. We use the formula for the union of two events. Substituting the values, we get 0.6 equals 0.5 plus 0.4 minus P of A intersect B. Solving gives P of A intersect B equals 0.3. Now using the conditional probability formula. Therefore, P of A given B equals 0.3 over 0.4, which is 0.75 or 3/4. Part A. Show that 2n-1 squared plus 2n plus 1 squared equals 8n squared plus 2. Expanding both squares, 4n squared minus 4n plus 1, plus 4n squared plus 4n plus 1. The minus 4n and plus 4n cancel, giving 8n squared plus 2. As required. Part B. Prove that the sum of the squares of any two consecutive odd integers is even. Method 1. Let the odd integers be 2n-1 and 2n plus 1. 8n squared plus 2 factors to 2 times 4n squared plus 1. Which is clearly divisible by 2. Hence the sum is even. Method 2. Let the integers be n and n plus 2. N squared plus n plus 2 squared equals 2 times n squared plus 2n plus 2. Also divisible by 2. So the sum is even. Given the derivative f prime of x equals 8x over root of 2x squared plus 1, and f of 1 equals 5, find f of x. We use substitution. Let u equal 2x squared plus 1, then do dx equals 4x. The integral becomes the integral of 2 over root u do. Integrating gives 4 root u plus c, which is 4 root of 2x squared plus 1 plus c. Using f of 1 equals 5, we find c equals 1. Therefore, f of x equals 4 root of 2x squared plus 1, plus 1. The graph of y equals f of x has a horizontal asymptote at y equals -1. Crosses the x-axis at -1 and 1. And the y-axis at 2. We must sketch y equals f of x all squared plus 1. Since fx squared is always non-negative, fx squared plus 1 is always at least 1. So no y values below 1. As x approaches plus or minus infinity, fx approaches -1. So fx squared plus 1 approaches 2. This gives a horizontal asymptote at y equals 2. At x equals -1 and x equals 1. F of x equals 0. So fx squared plus 1 equals 1. These are local minima. At x equals 0, f of 0 equals 2. So f of 0 squared plus 1 equals 5. This is a local maximum. The sketch should show a smooth curve with these key features. Let f of x equal x plus 3 over 4, and g of x equal 8x plus 5. Part A. Find g. Compose f of x. Substituting x plus 3 over 4 into g of x. Simplifying gives 2x plus 11. Part B. If g. Compose f of a equals 19, find a. 2a plus 11 equals 19, so a equals 4. Part A. Show that log base 9 of cos 2x plus 2 equals log base 3 of root of cos 2x plus 2. Using the change of base rule. Log base 9 of 9 is 2, so we get 1/2 log base 3, which equals log base 3 of the square root. Part B. Solve log base 3 of 2 sin x equals log base 9 of cos 2x plus 2 for x between 0 and pi over 2. Using Part A, we rewrite the right side. Since the logs are equal, the arguments are equal. Squaring both sides. Using the identity cos 2x equals 1 minus 2 sin squared x. Simplifying gives 6 sin squared x equals 3, so sin x equals 1 over root 2. Within the given interval, x equals pi over 4. A random variable x has probability density function f of x equals pi x over 36 times sine of pi x over 6. For x between 0 and 6. Find p of x between 0 and 3. We integrate by parts. U equals pi x over 36, dv equals sine of pi x over 6 dx. Applying integration by parts formula gives this expression. The first term evaluates to 0 at both limits. We are left with 1 over pi times sine of pi x over 6 evaluated from 0 to 3. This gives the probability as 1 over pi. A line L and a plane pi are given. The angle between them is 30 degrees. Find the possible values of p. The angle between the line and the normal to the plane is 60 degrees. Using the scalar product formula with the direction vectors. Computing the dot product gives 2p. This leads to the equation. Squaring and solving gives 7p squared equals 45. Therefore, p equals plus or minus 3 times root of 5 over 7. f of x equals e to the 2x minus 6e to the x plus 5. Part A. Find the largest A such that f has an inverse. Differentiating. F prime of x is 2e to the 2x minus 6e to the x. Which factors as 2e to the x times e to the x minus 3. Setting the derivative to 0, we get e to the x equals 3, so x equals lane 3. This is a minimum point, so the largest A for which f is 1 to 1 is lane 3. Part B. For this value of A, find the inverse function and its domain. Rewrite f of x as e to the x minus 3, all squared, minus 4. Solving for e to the x, and taking the negative root because x is less than or equal to lane 3. So x equals lane of 3 minus root of y plus 4. Therefore, the inverse function is f inverse of x equals lane of 3 minus root of x plus 4. The domain is from minus 4 inclusive to 5 exclusive. This concludes the walkthrough of section A. Good luck with your studies.